everybody. This is another week of Adventures in DevOps, and with me in the virtual studio, I guess, I have Will Button.
Hey, everyone.
Jonathan Hall.
Hey.
And our guest, Matt or Matthew Topol. Which one do you prefer?
Matt Topol.
Matt Topol. Okay, all right, I'll try one both.
Everybody, it always goes back and forth. Topol. It's Topol. Never goes, you know.
Okay, all right. Well, that's good to know. Do you want to introduce yourself to us and tell us, why you're here, why you're on the show?
Absolutely. So, obviously, Matt Topol. I'm a software engineer at Voltron Data currently, and I'm on the PMC for the Apache Arrow project. That's the project management committee. And I also wrote the book on Apache Arrow. There's just the one. At least currently, there's just the one. In-memory analytics with Apache Arrow. You can get it on Amazon. You can get it at PAC. But yeah, I'm here to talk about Apache Arrow and all things related to it.
That's great, because Apache Arrow is like my favorite data frame analytics library, and I've been using it all the time, and it's become like practically, I don't know, somewhere between a religion and a cult for me. I'm not sure how emotionally healthy that is, but that's,
Aren't
where we're
cults
at.
religions too? Like, can't you be both?
Should we really be doing this on the show?
Right.
I don't know.
I'm just trying to figure out how you get between two things that are the same thing.
Hold up, before we go down that path, we have another guest to introduce. We can't ignore our guest.
Who's with you there, Matt?
Who's your co-host there?
This would be Penny.
Penny?
She's a little old lady. She's about 15 years old.
She's very cute.
Very, very pretty. She's Diva.
As she should be.
I love my little kitty. I've had her for almost that entire time. We took her in off the street right before I moved up to Connecticut for work right out of college.
Wow.
Right on.
Yeah, and the vet estimated she was roughly a year and a half when I took her in, and I've had her ever since, which is actually really nice, because when you get your first job right out of college, and the first time you're living completely on your own without any roommates or anything, it's nice to have a living creature that relies on you when you come home to keep you company.
Right, for sure. I mean, it's totally that anchor point that you need.
Oh yeah, especially because they cuddle.
Yeah, right. They can't say the same for humans.
Some humans
might not want that from your human roommates.
Right.
That's true.
Depends.
There's rules that get involved at that point.
There's like restraining orders, once you get up in there.
Is this from experience, Jillian?
Oh, you never know. I've got some pretty crazy life stories. Although I don't think I'd want to live alone again, which just makes you like, I don't know. Must be a glutton for punishment over here.
I see that your
back to the show.
Your co-guest has abandoned us and left, so I think it's time to get back to an Arrow.
Yep.
I would like to hear. I mean, I've already talked to Matt, and I know that he's a real straight shooter. Drum, whatever, Arrow jokes here. There we go. Waiting for it. Well, you're letting me
I don't have the sound effects. I think only
I'm trying.
Look at him over here. He's like, just wait, I'll get it. We'll clean it up in post.
Oh,
there we go.
That did it for me.
Thank you.
Great.
Oh, I got it.
Here we go.
Maybe?
Man.
Oh my God. That was awkward.
Anyways.
So, I was going to say, I've interviewed Matt on a previous podcast. Shameless self-promotion. Cup of Go is a great podcast to listen to. So I know a little bit about Apache Arrow already, but I'm going to assume that people other than Jillian in our audience don't. Would you start by maybe introducing what Apache Arrow is, what problem it solves, and that sort of thing?
Yeah, sure. So Apache Arrow is an in-memory column-oriented data format. The intent there is that because the representation of the data in memory is identical to the way it's represented on the wire or anything like that, you can pass data back and forth through systems without the cost of serialization and deserialization. You can pass it between runtimes in the same process with zero copy. And the idea is that you can reduce the number of copies that are necessary to process data, while the data is also, since it's column-oriented, is also very, very efficient for lots of analytical and computational workflows. And there are implementations of the Arrow format in insert your language here. There's probably an Arrow implementation for it. Off the top of my head, there's Go, C++, C, Ruby, Rust, Python, Java, JavaScript, TypeScript, Julia, probably others I'm missing, but R, there's an R implementation. And the idea being, and because there's so many implementations in all these languages, and because the representation of it is identical in memory in no matter which language you're using, is extremely useful as data interchange, computational and interactive speed performance. And so you end up with a lot of systems that are using Arrow both as their internal memory format for computation, but also as just the data interchange. And the project, the Arrow project itself, has expanded beyond just that representation. You've got an RPC protocol, Arrow Flight. You've got an extension on that RPC protocol, Apache Arrow Flight SQL, which is a additional definitions for that protocol that are centered around using databases in SQL situations. There's ADBC, Arrow Database Connectivity, which is basically like ODBC, only it's Arrow native, and you get enormous performance gains over using JDBC or ODBC by using ADBC. And we've got different drivers implemented for ADBC, such as Snowflake was the most recent one. There's obviously Arrow Flight driver. There is Postgres and SQLite drivers, and we're also working on other drivers for different databases for ADBC there, which is itself just a kind of a C interface with a lot of drivers implemented, so that you can use it from anywhere. Yep, that's kind of it in a nutshell.
So whenever you talk about it being in memory and these different libraries, do you share just like a pointer to the same memory location, or do you actually just share the data and put each person wants a different copy of that data?
There's two different primary ways that the data is shared. There is an IPC protocol for going, across the wire or between processes, which is essentially a very small flat buffer message with some metadata, followed by the raw buffers, just the bytes as they are in memory. And the benefit there being that when something receives the IPC protocol, you don't have to copy or deserialize those body buffers. Whatever you receive that IPC protocol on, the bytes as they are what you want. And there's that tiny flat buffer message with the metadata to tell you how to interpret it. The other way of passing data back and forth is what's called the C data interface, which is a small C struct that effectively contains that same metadata, the format, is this a string array? Is this a int64 or whatever? It contains the information such as, the number of buffers that are there, the number of nulls in the column, the total length of the column, and then just the raw pointers to the memory. If there are two buffers, then you have, two pointers that point to just the raw body of the body buffer is there, and it's the raw memory. And it works the same way for complex columns like nested struct columns or list columns, because Arrow has a very thorough type system. And so in that case, you also have pointers to the children arrays in the same struct, so that when you pass data within the same process between different runtimes, you're just passing pointers.
Wow, that's
and
cool.
avoid copies.
It is very cool. Yeah, I really appreciate that you guys like did not mess around with the everybody is getting the same data all the time and just picked that as like, like, I don't know, that was like your line in the sand or something, because I work on a lot of interdisciplinary teams where everybody's using like different languages and different things. And Arrow's the only library that I've really found, like, no matter what, we're using Python, C++, R, usually it's like some mix of those in bioinformatics. Everybody really does get the exact same data, and it's very nice, because that does not typically happen, right? You'll get like these weird little like idiosyncrasies between data sets, whether or not people are accessing them in like, Python or R, and then people start to write these like libraries on top to make sure like, okay, when you read the data in with R, you need to make sure that you do this checking, and when you read it in with Python, you need to do this. But with Arrow,
Yep.
like all that has gone away.
Yeah, I mean the project itself, most of the implementations are in a single mono repo, which definitely helps a lot in a lot of the discussions and keeping things as close between the implementations as possible. Like, there's also an effort made in a lot of development to try to keep the interfaces, the actual APIs in the libraries, at least similar. Obviously, they're going to be more idiosyncratic for the individual languages, but we try to keep the APIs similar between the languages, just so that if you're jumping from, say, Pi Arrow to the C++ library or the Go library, you can still kind of orient yourself in what the functions do and stuff, because things are named similarly, the APIs are similar in the way they interact with data and stuff like that, to kind of keep that ease of use between the different languages. The Arrow project started back in 2016-ish. It was actually one of the co-creators of Arrow was Wes McKinney, who created Pandas.
So what are the typical, what are like the prime use cases for Arrow?
Anything to do with data?
Is there like a barrier to entry? Like if you've got X amount of data, it may or may not be worth it. But like once you pass this threshold, it's kind of a no-brainer.
So because Arrow is column oriented, if your primary workflow is very, very row oriented, then Arrow may not be as beneficial as you get larger and larger data sizes, if you need to access, lots of columns in a very row oriented way. Most analytical processes analytical workflows are accessing smaller numbers of columns, subsets of columns, and are going to highly benefit from column-oriented access for vectorized processes. And that's where Arrow really shines, especially for any kind of ETL or data transfer or computations, because the data is in that column-oriented format, even in memory. It means that you can use SIMD and other vectorization very, very efficiently with Arrow data. And so if you're, Meta released their open source computation engine Velox, which we're doing a lot of work with, and the internal memory format for Velox is effectively Arrow. DuckDB, the internal memory representation for DuckDB is effectively Arrow. It's not quite identical. There are some things that they do slightly differently because they found that in certain ways that are their optimal performance and things like that. But for the most part, it's mostly identical to Arrow, and we're actually working with them in a lot of ways to try to find those situations where they were like, this representation is more efficient for this, and trying to add those to the Arrow spec to reduce that kind of fracturing and keep keep Arrow relevant in all these spaces. And then you get the fact that it's extremely performant, not just for the internal computational aspects, but for getting the data in and out. DuckDB does provide an interface using Arrow's C data interface. You can get Arrow data directly out of DuckDB and avoid the copy, because it'll give you the pointers to the data that it allocated as the result data.
Oh, I got you. Right on.
And even on the row data, though.
What's up? What was it?
I was going to say, even on the row data, I had like a data set that was like 3 billion rows by, I don't know, like 12 or 15 columns, and the whole data pipeline ran in like a couple of hours on serverless data infrastructure too. So it was like, under the 16 gigs of memory.
Yeah, I mean,
my clients are cheap.
Absolutely. I mean, when I say a very row-oriented access pattern, I mean like explicitly, like you are looking at the value in every column, row by row, as the way you're accessing the data, which is actually fairly rare. Most workflows will work exactly the way you want them to and be better in a column-oriented fashion in most cases. There are cases where that row-oriented accessing is important, but they're actually fewer than you think.
So you've talked about databases here, and that's what I wanted to ask about. Like when Will asked where would you use Apache Arrow, and you said anywhere where you use data. Base is the word that springs to mind. Databases. Everybody uses a database. I'm assuming you need specific databases that are designed to work with Apache Arrow. You can't just like install a plugin and suddenly use Apache Arrow to query Postgres or something like that. Is that accurate? It's
actually hilarious that you use that as the example.
Okay.
There is work being done to create a Postgres plugin to provide a Arrow Flight SQL interface
that's awesome.
to Postgres.
Nice.
That would be very cool. Then I'd have vector databases, and I'd have Arrow, and I'd just have all the things that I wanted in Postgres.
But in general, you're right. You're right. You're right. The database needs to have the ability to ingest the Arrow data or export the Arrow data to actually leverage it, because it is itself, it's a format. It's a memory format. The database has to know what you're talking about to give it the data. But above and beyond just databases, services, processes, Arrow Flight is an RPC protocol. So if you're passing data around, you're creating a data service, Arrow is an exceptional way to do that as your memory format because of the efficiency. Because of the fact that you're reducing the number of copies as you pass that data around. You don't need to serialize and deserialize the data as it comes in and out. Now, if bandwidth is your problem there, the IPC protocol does have a compression option, and therefore, and that's where you kind of have to play with settings and the idea of going, is it, you get the benefits if you pass data around by not having to serialize or deserialize, but if you need the data to be smaller to pass it because of bandwidth reasons, you can compress it to get the faster network transfer at the cost of the compress and decompress at the end. Now, one of the benefits of most of the Arrow implementations will actually look at the size of the compressed buffer, and if it's not actually smaller, it'll throw it out and just use the uncompressed buffer.
Oh,
because the protocol allows the compression at the buffer level, and you can have compressed buffers and uncompressed buffers alongside one another, and so you can kind of get the best of both worlds as possible. Obviously it's going to depend on the implementation, taking advantage of it. And that's kind of the name of the game in a lot of the Arrow spec things, that the more active implementations, implement are more complete. And if you look at the Arrow documentation, the Arrow site, there's actually like a full there's a full table kind of going of like the main implementations and what features are or are not implemented of the Arrow spec in all of them. The most complete ones are the C++, the Java, and the Go, and the Rust are the most complete. The Pi Arrow is super complete because it's just a thin veneer on the Python's just thin veneer on the C++ library. Like a lot of like there's like kind of like two different types of implementations there, where you have the native implementations, and then you have the implementations that are just kind of wrappers around the C++.
Yeah, which I am here for, because with the Python implementation, it works really well with a library called Cython, which lets you call like kind of lower level C or C++. And with the data set that I was talking about earlier, where it was 3 billion rows, I was getting to this point where it was running for like 2 or 3 hours, and then there would just be a memory leak like somewhere, and I couldn't figure out where it was. And so instead of, figuring out where it was, I was like, well, screw this. I'm just going to write everything in Cython, because that's how I solve these kinds of problems. And then the memory use of like the entire program as a whole, like just like dropped. And I was very impressed with myself over that one. So that was great.
Very nice. Yeah, I played
and
a little
Arrow
bit.
too, of course.
I played a little bit with the Cython stuff. Like the Pi Arrow is actually uses Cython itself to do the communication with the Python and the C++ Arrow library. So it's using Cython right directly there, anyways.
I took a look at the Pi Arrow implementation. It is almost all Cython, which is really cool.
I played a little bit around with it, and it can get confusing sometimes. Cython is not the easiest thing to play with, so all the power to you there.
It's better than it used to be, but yeah, it is kind of, it takes some getting used to, I guess. But it's great if you're interfacing like with other libraries as well. Like I work with a lot of other file formats, which are, maybe like 10, 20 years old, and a lot of them are like, C, C++, these kind of, they're not legacy because they still exist, but they're before all kind of the nice libraries that we have now. So being able to like integrate things with Cython is nice for me personally. I don't know about anybody else, just me. I'm really curious about how you got onto an Apache project. Were you working on it before it was an Apache project? Like, I've always kind of wondered, because the Apache, it sounds like, this kind of like very glamorous thing, like, ooh, it's an Apache project, but I have no idea how they get started, how one gets to be working on Apache projects. I'd really like to hear more about that
glamorous.
process.
I can say as a fellow PNC on an Apache project.
Oh no, is it just unpaid labor, or like all my hopes and dreams about to be dashed here?
Oh, it is absolutely unpaid labor. Absolutely unpaid labor.
Oh, okay.
Actually, I'm lucky, and I'm extremely lucky in that my current position at Voltron Data is I work on the Arrow library. That's my day job now. Like I get paid to work on the Arrow library. That's what I do. So I'm very, very lucky in that respect. As far as how I got started here, like I wasn't part of the Arrow inception. Like I learned about the project separately entirely. The general process for something becoming an Apache project is you go through what's called incubator, and you talk with the Apache Foundation, and they'll usually give you someone who's very familiar with the Apache way of doing things, and then you eventually can become a top level Apache project in and of itself. And mostly it's about governance. It's about the way you operate the governance of the project. Is the big part of what makes something an Apache thing. But as far as like how I got started in it there, before I worked at Voltron, I joined Voltron last year. Before that, I worked at a financial software company, Backset Research Systems. And I worked on a product that was effectively basically just a giant vector calculator. That's what I worked on. The project is basically just a giant vector calculator. I started working on the engine itself, eventually moved up to working on the application side of things and serverization and stuff. And I had a project that I was trying to do to create visualizations. Users can put in parameters, like I want the standard deviation of the price for the last 200 days of the entire S&P 500. and they get a column of that. And they can have all their columns and the parameters, and we wanted to create the ability for them to create charts from that report. Chart this column against that column, and so on and so forth. And the problem you run into is, well, at any time a user can add or remove a column. So I do not have a static schema, and I can have anywhere from 10 to 2,000 columns. I can have anywhere from 100 to 3.5 million rows. And at any point, user can add or change columns that will completely change all of that. And somehow I need to be able to create interactive speed charts. So I went to a Hadoop conference and was just asking around. This was like in 2018, I think. I was just kind of asking around people for ideas of what could possibly enable me to do this so that I could keep updating the data and do all these things and whatnot. And everybody told me I had too many requirements.
I would tend to agree with them.
And, well, of course, I'm like,
yeah, you want too many things.
and the problem is like, okay, but those are my requirements.
Right.
And so I learned about Arrow at that Hadoop conference. And I also came across Apache Drill, which is...
That's superset? Because you keep saying charts and I keep thinking superset.
Superset either didn't exist yet or wasn't very popular yet at the time that this happened.
It might not have. I think it might have been incubating around that.
Drill,
I don't know.
I mean, Drill is a distributed compute engine. If you've heard of Dremio, Dremio was built on Drill originally.
Mm-hmm.
And actually, the other fun story is that Arrow itself actually came out of Drill's internal vector representations. Apache Drill's value vectors are what became Arrow. So anyways, I ended up hacking together this system that basically I made a Python service using PyArrow that accepted an Arrow IPC table and wrote the data as a Parquet file to an HDFS cluster.
Very nice.
And then I had Apache Drill running on the same nodes as the data nodes of the HDFS cluster to get the short circuit reads. So that basically what happened is you do your report, you get the compute. It writes the result set as a Parquet file, and then when you want a chart, you just send the front end just sends a request to that service, which creates SQL from it and sends it to the Drill cluster, which queries that Parquet file and returns the results. And if they add columns or change the data at all, I just overwrite it with a new Parquet file. The next query goes in, Drill goes, oh, the metadata says that this has been rewritten. Refresh the metadata, and then run the query. And because the Drill nodes are running on the same boxes as the HDFS data clusters, it's all super fast and interactive speed. Sub-second queries, the whole 9 yards. And that was kind of my introduction to Arrow in the first place, though. From there, I was building other services using Go. And I was like, I want to use Arrow for this because it makes sense. And I was, oh, there's a Go library for Arrow. Perfect. And I started going through it and finding, oh, it's missing this feature. It's missing that feature. Oh, I'll contribute this thing. I'll contribute that thing. And I just kept doing that because, well, I wanted to do it in Go and not have to rewrite the entire thing in C++. So I just kept adding to the Go library instead. And eventually they made me a committer, and I became more active on the mailing lists. And then I was giving talks at conferences about how we were using Arrow at FactSet, and then Pact, the book publishing company, reached out to me and was like, would you like to write a book? And And I was like, wait, what? And I wrote a book.
That is very cool, though.
I did not expect to write a book.
Tell us about that then. You said you didn't expect to write a book. What's the story behind the book?
What was that? I mean, that was the story. I was
Okay. Well, I mean, but how did that lead to a book specifically? Did they ask you to write a book?
Literally, yes.
Okay. All right.
Pact is the publisher for the book, and I got an email one day from a product manager at Pact, and they were like, we want to have a book on Arrow. Would you be willing to write a book? And at first, I thought that they were asking me to consult on a book, and I was like, yeah, sure, I'd love to consult on a book. And then I met with them, and they were like, no, we want you to write a book. I'm like, oh. As far as I can tell, they reached out to several people in the community. Mm-hmm. I just happened to be the guy that responded. Yeah.
Cool. And now you're world famous among Arrow users.
I mean, now you have a book.
The book's selling well. I mean, it's a tech book, so it's selling well for a tech book.
Yeah.
I mean, the primary thing I noticed, like, shockingly, my general way of handling interactions in keeping people engaged is humor. I know, weird, right? And so I found that people people kind of really enjoy my presentation style, which tends to involve lots of memes and jokes.
Yeah. Nice.
And so when I was writing the book, my primary goal there was, I don't want this to be a dry book. Mm-hmm. I want this to be engaging, which means I need to write it in my voice and find some way to translate the way I give presentations. And so there's just puns. There are puns everywhere. Nice. One of the ones I'm most proud of is a chapter called ODBC Takes an Arrow to the Knee.
Very nice.
There's another spot in there because I talk about using mmap and how you can leverage the Arrow IPC format and mmap to kind of keep memory usage down in certain ways and other things. And then I explain how that works. So I basically explain how virtual paging works. Mm-hmm. But the heading for that section before that is just TLDR, computers are magic.
Okay.
Yeah. And you can kind of get the tone from there. Yeah. From the I tried as best as I could to kind of keep that kind of fun tone with the book. And the other selling point of it is that it has examples and usage in Python, C++, and Go throughout the book.
Oh, wow.
Which is kind of different for tech books, which usually will focus in one language.
Yeah.
But kind of one of the important aspects of Arrow is that interoperability aspect of things. And so I wanted to have the examples in at least 2, if not 3 languages to kind of showcase that. And then I went around to conferences talking about the book and giving out free copies of the book, and now I go around to conferences as part of Voltron Data talking about the work we're doing with Arrow in general.
That is very cool. It's really nice when jobs kind of embrace like open source software. I think that's so much more common now than it used to be. It seemed like jobs were like so like afraid of this, like, oh no, we can't have like our software just, out on the web. How will we have any intellectual property or make money? And now it just seems to be so much more of a given of like, there's software, it's out there. Let's go use it.
I mean, so Voltron Data itself, I mentioned that Wes McKinney was one of the co-creators of Arrow. He's also one of the co-founders of Voltron Data. Mm. And Voltron, we like Arrow itself is a primary aspect of the startup and the work we're doing. And so a large amount of the current maintainers of Arrow actually do work at Voltron as we're moving through things. And so, it's really cool because there's that huge support of the Arrow community, and the fact that the better the Arrow community does, that helps out Voltron Data and itself also. And so I like being on the open source side of things, where, like I said, my day job is I just get to work on the open source libraries, which makes me really, really happy.
That's
for
great.
sure.
That's why I tell everybody, like whoever asks me, like, oh, how do I get a job? I'm like, go find like an open source software you can contribute to, or start writing, start just getting your work out there.
Absolutely. I mean, if you can get your like I said, I just started contributing stuff, new features and things to Arrow, and that's how I ended up down this whole path. And that's exactly it. Like, find a project you like, contribute to it. There's always going to be features or things people want from it. You can find stuff for it and just have fun, be part of the community. And, I've been working for the last, one of my side things I've been doing for a long while now is I've been trying to grow the Arrow Go community, because Python is your big go-to for data science nowadays. When you think about data science, you don't think Go currently. I've been trying to change that a bit.
Good job. I hope that you have a great success there. I don't see why Go isn't used for stuff like that.
Well, the problem is really the lack of the widely used libraries. Really, what it is.
Right.
There is no real data frame thing for Go like you have pandas or polars for Python. Mm-hmm. And I've been trying to kind of promote Arrow as that for Go. I created a Parquet implementation in Go that interoperates with Arrow. I'm contributing to the Iceberg repo now. I'm making a Go Iceberg implementation.
What is Iceberg? So I was looking, all right, we're going to get real off tangent here for a minute. I was looking at their website and I was just like, what? I don't get it. Like, what is this? What is it? I don't know.
Iceberg is quote unquote a table format. Basically, it's a bunch of metadata on top of other data files.
But I already have Parquet files. Why do I need Iceberg?
So Parquet files are immutable. If you want to update Parquet file, you have to rewrite it. And also, then you lose whatever was there before. Iceberg metadata gives you time travel. You can see snapshots at previous versions of the table. You can do partitioning by grouping the multiple Parquet files together as one table, and get highly efficient reads and lookups. You also can have Parquet files that define these are data that was deleted. These are rows that were deleted from the table, without having to rewrite the entire table. It's a way of getting much more efficient scans, joins, lookups across a table that is made up of multiple and many data files, and allowing you to have that time travel snapshotting ability to see what the table looked like at different points in time, which for a lot of workflows is very, very important. It also means that you can get much more easily ACID compliance across the table of data updates, deletes. You can get transactional interactions with the table, so on and so forth. You got Iceberg, or you got Delta, or you got Apache Hoodie.
Apache what?
Hoodie, HUDI.
Hoodie. Okay.
Hoodie.
All right. I just want to make
that's
sure.
The other.
That's great.
Those are the competing table format things. Personally, I think Iceberg's going to be the one that wins. That's my personal opinion.
That is very cool, except for the history. I don't know that I want that much adult supervision on what I'm doing. I understand why it's useful. I'm just a little bit like, oh no, this is going to tell on me, you guys.
It's like looking at your Git commit history and you're like, oh, We're going to
So,
squash
I
that.
actually contributed once to Apache Superset, and they were like, "Are you sure you don't want to squash these commits?" And I was like, "No, it's fine." They never asked me to commit again.
I think that's a really good point because you were talking earlier about using open source as a way to land a job. But I think one of the other benefits of contributing to open source is that you learn how to work in the constraints of a larger community. When you get ready to make that first contribution, you'll get feedback. Hey, squash your commits, or hey, you need to test to cover this. And I think it actually helps you level up your skills really, really quickly so that when you do land that job, you're able to start contributing to your new role a lot faster than you would be able to just out of school.
Oh, absolutely, absolutely. I mean,
Definitely.
there's lots of things that I have learned from contributing to different projects, and also like some projects can get really, really interesting in the way they solve certain problems, and just seeing the way that certain problems are solved by different projects in and of itself is really, really cool.
Oh, for sure. Yeah.
Yeah, those peopling skills are really important. Like, back in the day when I occasionally hired people, I'd be like, "Oh, have you worked on any projects?" And then how go see how they deal with all that. And that was kind of a big deciding factor on whether or not somebody could play nice with the other children on the playground while working, on a collaborative project.
It is fun. It is
So,
fun. Project collaboration is always an interesting adventure.
Right. So what's on the future for Arrow?
So there's a couple things. I mean, like I said, we're adding the new data types to kind of make keep the relevance and also like interact better with things like DuckDB and Velox and whatnot. One of the things I'm directly working on is improving the non-CPU APIs for the Arrow library, the Arrow C++ library. Like for example, I mentioned there's the C data interface for passing data back and forth between runtimes in a process. We recently added a extension to that of a device array, so that you can take data on, let's say, a GPU, and pass that between runtimes. Like from Python to C++ to share different libraries, without having to copy the data back to the CPU and then back to the device. But you can leave the data on the device the whole time and pass the device pointers through it.
Wow.
And so we're kind of like pushing that API up through the library to make it easier to manipulate and to leverage non-CPU memory with Arrow in the existing libraries. Like currently there's a couple spots where it kind of blindly tries to validate things, and then if your data is not on the CPU, if you have a GPU array, it just blows up because the pointers are device pointers. Because it's like, oh, I'm just going to validate this thing. It's like, oh wait, no, that's cool. So I'm working through finding and fixing those spots in the library to make sure that it's much more cohesive and consistent throughout it. And there's other people are looking at better interoperability with other ML spaces, like PyTorch and those other like ML libraries, and seeing how we can improve the interoperability of Arrow with those libraries. There's a large effort, GeoArrow and GeoParquet, for geolocation stuff and geographical data sets and representing them in good ways. And there's a whole effort going on there. And then, like I mentioned, ADBC with database interactions. We have the drivers we have. We're trying to improve and add more drivers. I'm big. I'm also in that effort too, and we're trying to. Like I have I have an issue filed with BigQuery to expose some Arrow stuff so that I can create a BigQuery driver for ADBC. And things like that. So the as far as what's future, what's in the future, we're just kind of branching in lots of different places because it's a large community.
one thing I'm curious about, since we're talking about in-memory data, like memory is ephemeral by nature and not guaranteed. So whenever you're accessing the Arrow data, do the libraries validate that memory location is still valid, or is that up to the implementer, or how do you handle that, or is that not a concern at all?
In most cases, most of the it's generally up to the implementer of the library for the language.
Okay.
Most, like for example, C++ library uses a lot of shared pointers and otherwise to kind of ensure the memory stays alive. There are certain APIs that are explicitly marked as up to the caller to ensure that the pointer stays valid.
Gotcha.
And so there, the exact way of managing the memory is going to differ slightly between library to library because different languages have different ways of doing it.
Yeah.
But Arrow also becomes a very, very efficient way to handle larger than memory data sets. The Arrow, the C++ and Python libraries have the dataset library for Arrow, which is explicitly for handling larger than memory data sets and efficiently handling filtering and querying and doing joins and things like that to kind of manage streaming the data through.
Okay, gotcha. Yeah, that seems like a whole rabbit hole that could go quite deep.
It does, and it is.
I'm just going to sit over here in the corner with my select star and be happy that someone else is working on that.
That's right. That's where I'm at with all this too. Like, oh, look at all these people writing these nice libraries for me. I would also really like it if ChatGPT could do a better job with the C++ Arrow implementation. If anybody is out there, like listening to my wish list, I would very much appreciate that because I don't write C++ all the time.
What did
it just gave me really weird responses. I was kind of, I don't know. It wasn't completely useless, but it was not, let's say, correct either. And I was just thinking it would be so nice because C++, you have to remember so many things, especially if you go and code in Perl or Python or something for a while. You don't have to remember types, and then you go back to C++. You're like, oh, what are all these words? What is this? It would just be nice if ChatGPT could take care of some of that for me. I don't think I've never coded in Go, so I don't have any opinion on that.
Oh, you should check out the Cup of Go podcast. It has some really good pointers and tips on using that.
I'm sure it does.
Yeah.
It's very, very nice. I like it.
There's also a really cool YouTube channel called Boldly Go you should check out. Shameless self-promotion.
Yeah.
That's what the show is for.
I do like Boldly Go.
Mathematics at least 3 times.
Boldly Go, your YouTube channel is actually really, really well done.
Oh, well, thanks. I had a really great editor I found through a mutual acquaintance.
Oh, nice. That's probably good for him because that mutual counterpart's probably leaving that editor hanging recently.
I know, going off and running marathons instead of making YouTube videos. What's wrong with you? All right. Well, I think we got through all my questions at least. Did anybody else have any questions? Or Matt, was there anything else you wanted to bring up?
No, I mean, I think I've mentioned all the things I can think of. I got, let's see here. I'll be at a conference in November in Sweden, actually.
Sweden.
Talking about Arrow and stuff, which will be a lot of fun.
Cool.
Nice.
Well, if you happen to fly through Amsterdam, stop by. We can have a coffee together.
So the flight actually drops me in Copenhagen.
Okay. Cool.
And then I take a train from there.
That'll be a fun trip.
Yeah, I'm looking forward to it. I've never been before, so it'll be great.
I can only imagine it. It's like the Tom Hanks movie Polar Express.
Or it's the movie with the train that I don't know. There was some kind of apocalypse, and the only thing that's running is that train, and it's the post-apocalyptic.
I know
yeah, that was that was a Brad Pitt movie, wasn't it?
I don't remember now. I saw it a while ago, but hopefully your trip doesn't end up like that.
I hope so too.
Yeah, I think we can all hope that.
Giant apocalypse happens while I'm on the train. It's gonna be, they step off and it's just fire everywhere.
Yeah, All right, let's not go putting those kind of thoughts into the universe. Where can people get a hold of you if they, want you to be like, Matt, come talk about all the cool Arrow stuff, or write us a book and make millions of dollars, that kind of thing.
I mean, I am easily found on GitHub. I'm Zero Shade. You can find me on Twitter with the same name, Zero Shade. You can find me on Mastodon, LinkedIn. You can search me by name. You'll find I have the author of In-Memory Analytics, Apache Arrow, in my little name thing, so you can find me easily on LinkedIn. All of the above. And the book is available on Amazon or from Pat's website directly.
Nice. Well, I guess let's do some picks. Who wants to go first?
I can go first.
I can go.
No. Will, you go.
Well, now you two have to battle it out. I mean,
Right.
that's clearly the only solution.
Fight.
Right.
Jonathan's got his green screen here, so there should be some really great special effects happening.
Yeah, I can't compete with that.
You know.
So I'll go then, since we're just sitting here. So on topic, somehow recently, YouTube, which I have been watching, has started showing me videos from Blumenek. I think that's how you pronounce it, which is kind of interesting channel about arrows. So I thought it would be perfect to talk about today. He's an archer who makes short little videos about archery. And I've never been an archer, but it's kind of cool because he talks about like fantasy movies and video games and are these things they do in these settings, are they realistic? And he kind of demonstrates. So a recent video I watched was taking a scene from Robin Hood Men in Tights, I think, where the character shoots like 6 arrows at once and they pin a guy to the wall. He's like, is this possible? So he starts with 1 arrow, then 2, then 3, and works his way up, and talks about is there any plausibility to this? And I was honestly surprised at how not completely bogus some of these movies and video games are. So that's my pick for the week is Blumenek, Blumineck on YouTube.
Cool. I will stay on topic then. My pick for today is going to be the diamond archery bow from Bowtech. I have one. Go out in the backyard, fire off some arrows, and it's actually a surprisingly fun hobby because you don't need a lot of space to do it. You do need like a reliable backstop in case your arrow doesn't go where you intended it to go. So that's one tip worth noting. But it's actually fun because there's a lot of subtleties to archery that are fun to just work on, from working on holding your breath and controlling the release and then setting the tension on the bow. You can actually turn it into a strength workout by adjusting the tension. And you can get started with it relatively inexpensive. You can find a bow, either new or used, for any budget, but it's actually a lot of fun. So my personal bow is a diamond archery bow from Bowtech, and yeah, there you go.
Cool. What about you, Matt? Do you have any picks?
I guess I'll go with the Baldur's Gate 3 I've been playing.
Nice.
Just like I've been playing that constantly.
I'm literally downloading that right now on my brand new Steam Deck.
Ooh.
I haven't.
You have the Steam Deck?
It
When
just
was
arrived.
that to pick? I want to know about it.
It just arrived today. That's why I can't pick it yet. I haven't played anything on it, so it looks cool. I don't know if it's fun yet. I haven't tried it, but I've played Baldur's Gate 3. I played the pre-release about 2.5 years ago. It's been that long that I actually looked at it. It was a week before my son was born. It was the last time I played it.
That's
Imagine
that.
that. Maybe I'll have a chance now with the Steam Deck to play it again.
Now
that it's finally been released.
That means you need to have another baby.
I do have another baby.
And talk about another baby. Like baby twins.
Clearly, he does not need sleep.
No. I mean, how old is the youngest one now? You could have another one.
So stay tuned. I'll probably be picking a Steam Deck in a week or two once I've had a chance to actually use it.
And a new kid. You got to keep the velocity up.
Right.
Yeah,
right.
keep that velocity going.
Gotta supply me with ever constant baby pictures. That's what I need. All right. Well, I'll just keep on, I guess, the video game and archery theme and pick Horizon Forbidden West. That is a really fun game, and it has like very smooth mechanics in it. So you like run around and jump and climb and shoot bows, and it's a very cool world to
I played the
run
first
around
one.
and explore. The first one had really good mechanics too, but the second one is like, I don't know. They went like all in on the mechanics and the very pretty scenery because that seemed to be what everybody liked the best. And it's nice when developers, like when a game studio actually listens, they're like, oh, these are the things that people like, and so let's keep them. Unlike Sonic the Hedgehog, like Sega, I'm looking at you over here.
Hey, Sonic Frontiers was actually pretty good.
I haven't played that one yet. I gave up after, I forget. There was one I played when my daughter was little. I don't remember what it's called now, but then I was like, no more. I'm just gonna stick with the like Sega Genesis emulator Sonics and like play like Sonic 3 over and over and over again. All right, but anyway, yeah, exactly, as one should. And then my other pick is a book. It's called $1 Million Outlines, which was recommended to me by one of my sisters. And I've been kind of on this kick lately of understanding the psychology of story, mostly because it's really interesting. And I think it really fits whether you want to write fiction or nonfiction. In fact, like Matt here was saying, the best nonfiction is the kind that's not really dry and has like, at least some kind of human, I don't know, an intervention in it, I guess. So kind of understanding these same sort of like flows of stories and how you have these emotional hooks and how you like create a point and build up to that point, all that kind of thing is really relevant whether you want to write fiction or nonfiction because it's all just, human psychology and neuroscience, which is kind of nice for me because every once in a while I like to get back to my neuroscience roots. So that's it. $1 Million Outline. Go read it. It's fun.
Have you read Joseph Campbell, I think, Man with 1,000 Faces? I think that's the right title.
No, I've read, what is it, like Power, I've read a bunch of the other ones, like Power of Myth, or Neil Gaiman has a really good book about Norse mythology, and it covers a lot of this kind of like the psychology behind it, like, well, why do we have these stories in the first place? And it seems like there's some kind of like very common human psychological underpinning that goes like, it's fascinating because it goes like across cultures and these places where people, likely didn't talk to each other, right? Like Norse mythology and Greek mythology, and you see all these same kind of similar themes.
Yeah,
so I was on a deep dive with that for a while.
Well, I think one of the more interesting things I've seen is when people draw the similarities between the different mythical creatures in like the mythologies of different places that are effectively similar creatures in completely unconnected cultures, and then do the trying to like reverse engineer. Okay, what is it that was in that environment that led to those myths and that thought of that creature that showed up in these two completely unconnected cultures, and it's really interesting when people do that. Like almost every culture has a vampire type myth. Almost every culture has a dragon or other large lizard myth. What was that, Jonathan?
I said every culture must have met my mother-in-law then.
Oh no.
I'm totally kidding. I love my mother-in-law. She's a sweet lady. There's nothing wrong with her. I just couldn't think of who else to say. I didn't want to say my wife.
Sacrifice it all for the punchline.
Definitely would have been the wrong thing to say.
Well played.
Team player.
Like
cute baby pictures ideas. That never gets you in trouble.
My mother-in-law doesn't even speak English, so there's no way she'll ever hear this. So
that's how you do it safely.
No, listen, mother-in-law, man, me and my in-laws don't speak the same language either, and yet they always know things, right? Like always, they always know things. And your kids are getting older; they'll start telling on you soon. Like it's all downhill from here. Which is why everybody should just have more babies, so that I can look at the baby pictures.
Can those babies be like fuzzy with fur and be kittens instead?
Yeah, that's fine. I'll accept that. All right. Well, I think the time of the show where we've gotten real off topic has finally arrived, or might have arrived from the beginning of the show. I'm not sure. So we're going to sign off for this week, and we will see you all next week. Bye.
Right on. See everyone.